Your AI demo answers 3 questions perfectly. Production answers 30,000 questions, invents a refund policy, and teaches the support team the meaning of observability. These 5 repositories measure different parts of that problem. First is Promptfoo. Promptfoo treats prompts, models, agents, and retrieval systems as a configurable test matrix. It can compare providers, run assertions, execute redtem cases, and fit into continuous integration. Use case: compare 3 support prompts across 2 models before release. Observable example: a dataset contains shipping, refund, abuse, and prompt injection cases. Issues check required policy citations, forbidden promises, structured output, and latency. Limitation: a configuration file is only as good as its cases and assertions. Passing 20 cheerful examples does not prove safety. Decision: choose Promptfoo for repeatable pre-release comparisons, regression tests, and red team suites. Second is Langfuse. Langfuse focuses on the lifecycle around production, LLM applications, traces, observations, datasets, evaluations, metrics, and prompt management. Use case: diagnose why a deployed RAG assistant became slower and less accurate after a prompt change. Observable example: one trace shows retrieval queries, selected chunks, model call, token use, latency, user feedback, and the prompt version. Failed traces become a dataset for regression testing. Limitation: traces can contain sensitive prompts, documents, identifiers, and tool results. Collection without redaction and retention policy creates a second data problem. Decision: choose Langfuse when production tracing and the feedback to evaluation loop are central. Third is Arize Phoenix. Phoenix provides open-source observability and evaluation with strong tracing and analysis for LLM and retrieval systems. Use case: inspect a question answering system where the final response is wrong even though the model appears reasonable. Observable example: trace the request through query, rewriting, retrieval, re-ranking, and generation. Compare retrieved evidence with the answer and identify whether the failure began in search or synthesis. Limitation: instrumentation requires discipline. Missing spans or inconsistent attributes can make a beautiful trace tell only half the story. Decision: choose Phoenix when you need deep analysis across retrieval and agent spans, especially in an open telemetry-oriented stack. Fourth is DeepEval. DeepEval provides a test framework style for LLM evaluation with metrics that can be attached to cases and run as part of development. Use case: prevent a medical document summarizer from dropping medication changes. Observable example: each test includes source text, expected facts, and evaluation criteria for faithfulness, completeness, and forbidden additions. Failures appear like software test results. Limitation: model-based metrics are not objective truth. Judge choice, rubric wording, and thresholds can change scores. High-stakes facts still need deterministic checks and expert review. Decision: choose DeepEval when the team wants evaluation to feel like writing and running tests. Fifth is OpenAI Evals. OpenAI Evals is a framework and registry for defining and running model or system evaluations. Use case: create a custom benchmark for an internal coding assistant that must identify ownership. Propose a patch and respect scope. Observable example: tasks point to frozen repository states. Graders run behavior-based tests and the evaluation records whether the complete system resolves each issue. Limitation: benchmark construction is difficult. Contamination, underspecified tasks, and flawed graders can turn a precise score into a precise mistake. Decision: choose OpenAI Evals when you need a customizable benchmark harness and are prepared to validate the tasks themselves. These tools are not direct replacements. Promptfoo asks, does this prompt and model combination pass our test matrix? Langfuse asks, what happened in production across versions and users? Phoenix asks, where inside the traced AI pipeline did the failure emerge? DeepEval asks, can we express quality checks as repeatable tests? OpenAI Evals asks, how do we define and run a broader benchmark? A practical minimum stack has 3 loops. Before release, run a frozen regression and red team set. In production, capture redacted traces, outcome signals, and prompt versions. After failure, convert representative traces into new tests. Here is that lifecycle for one support RAG assistant. Begin with a frozen evaluation set assembled from resolved tickets, policy edge cases, and deliberately adversarial questions. Each case stores the user request, approved evidence, expected action, forbidden claims, and escalation rule. Split cases so the team cannot tune repeatedly on the final release set. Use deterministic graders wherever the outcome is crisp. A refund promise over the approved limit is a rule violation. A citation must point to a retrieved document and a quoted claim must exist in that document. Required JSON must parse a tool call, must use the approved account. These checks should not be delegated to another model simply because model judging is fashionable. Use calibrated model judges for qualities that resist exact matching, completeness, clarity, grounded synthesis, or whether an explanation answers the real question. Give the judge an explicit rubric and source evidence. Compare its labels with expert reviewers, measure disagreement, and investigate the cases where confidence is high but humans disagree. Before release, Promptfoo or DeepEval can execute the matrix across the old and new system. OpenAI Evals can host a broader custom benchmark when the task requires frozen environments or behavioral graders. The release gate should name actual tolerances, no regression on critical policy cases, a minimum grounded answer rate, a latency ceiling, and 0 unauthorized actions. After deployment, Langfuse or Phoenix captures the redacted trace, query, retrieval candidates, selected chunks, model version, prompt version, tool calls, response, latency, and outcome. The trace must carry enough identifiers to reconstruct the system state without storing unnecessary personal data. When a user reports a failure, do not patch the prompt first. Classify the first broken stage. Did query rewriting erase an important detail? Did retrieval miss the governing policy? Did re-ranking select an outdated chunk? Did generation contradict good evidence? Did the tool execute incorrectly? Phoenix-style span analysis helps separate those causes, while production traces preserve the actual inputs. Then convert the failure into the smallest durable test. Add a deterministic assertion if possible. Add a judged rubric only when necessary. Run the old and proposed systems against the expanded suite. This trace-to-test loop is how observability becomes engineering rather than surveillance. Track uncertainty in the dashboard. Show sample size, confidence intervals where appropriate, case severity, and disagreement, not only one average score. A 95% pass rate can hide total failure on the 5% of requests involving money or safety. Weighting must follow consequence, not frequency alone. Finally, rehearse rollback. Store the model, prompt, retriever, index, tool, and configuration versions used for every release. If the new system violates a gate in production, the team should know exactly which version to restore and which traces to preserve for investigation. Assign an owner to every metric and failure queue. A dashboard with no release authority becomes wallpaper. The owner decides when a failed case blocks deployment, who reviews judge drift, how quickly privacy incidents are investigated, and when a production trace becomes a permanent regression test. Do not use thumbs up as the only metric. Users may approve fluent answers whose facts are wrong. Combine explicit feedback with task completion, citation validity, tool outcomes, escalation, and expert review. Version everything: model, prompt, tools, retrieval index, evaluation set, and judge. Otherwise, a score change has 6 suspects. For model judges, calibrate against human labels. Measure agreement and inspect disagreements. Use multiple judges or deterministic checks where consequence is high. Protect the data, redact secrets and personal identifiers before tracing. Limit access and retention. Sampling may be safer than storing every interaction forever. The purpose of evaluation is not to create a dashboard with green circles. It is to make a release decision, locate failure, and prove whether the next change helped. Choose the repository that answers the question your team actually has, then connect pre-release tests to production evidence so the system keeps learning after the demo